Okay, so what we're going to be talking about today is how we solve exponential equations using logarithms or solving log equations using exponentials. So we're going to kind of get into a little bit of that. We won't get very far into the lesson because we don't have a whole lot of time, but we'll get partway through. Are you guys ready? Sure. Okay. All right, so let's turn the page. We're going to do a little bit of review on how to solve some basic exponential equations. Okay. And these should look very familiar because we just got done talking about this, right? What do you notice about this exponential equation? We have common bases already. Good. So if we have common bases to start with, what can we do? What does that mean? Good. Set those exponents equal to one another. Excellent. Okay. Exponents are equal to one another. I want to add over what? I want to add over the x. I want to add over the 2x. Good. So that gives me 3 equals x. So that wasn't bad, right? Why? Because negative x plus 2x is positive 1x. Any problems with that? Good to go? Next one. All right. 3 raised to the 1 minus 2x equals 243. What do we want? Yeah, I definitely want a common base, right? So what is my common base going to be? Yeah, and this should give you a hint. We know that we can't change the base of 3 for the left-hand side, so the other side we're hoping is going to be 3. So can I make 243 into something with a base of 3? Yeah, 3 to the what power? 5th. Great. Excellent. Now set the exponents. Good. 1 minus 2x equals 5. So negative 2x equals 4 when we subtract over that 1. And divide by negative 2, which gives us x equals negative 2. Sorry, guys. Everything's popping up all over the place. Okay? What do you think? Easy, right? All right. Let's try the next one. Now this one's a little bit different. Why? Okay. Why else is it different? Good. I have to change both of the bases here, right? So my common base is going to be 2. Good. So how am I going to rewrite 4 with a base of 2? 2 squared. And that's going to be raised to the 2b minus 3 equals 2 cubed, yep, which is going to be raised to the 1 minus b. Great. Very good. We're going to distribute, right? So we're going to distribute through the exponent. We're going to multiply those exponents. Raise a power to power, we multiply. So this becomes what? 4b minus 6 equals? Good, 3 minus 3b. And notice I skipped that step. I knew that my bases were equal, so I know I was going to set my exponents equal to one another, so I went ahead and skipped over that in-between step, intermediate step. Add 3b, okay, so if I add this 3b over, this is going to give me, good. Oh, slow down. Okay. Add the 6. 7b equals 9. What am I going to do? Divide by 7. b equals 9 sevenths. Great. All right, how are we feeling? Give you 1 minute, please. Okay, hold on. Okay, so do we have the hang of it? Do we need to do more of these? I kind of want to move on to what we're actually going to be doing. For some reason, I messed up my variables. I'm not exactly sure how I did that. So just we're going to ignore this. Okay. What we're going to be able to do is we're going to be able to take exponential equations, and we're going to be able to solve them by either putting them into log form or taking the log of both sides. So we're going to look at both of those options. So for each one of these questions, we're actually going to do it using two different methods. Okay? So let's look at the first one. We've got 7 raised to the 3x equals 20. Okay? Now, my initial thought is, oh, I need a common base. But can I get a common base here? No. So there has to be another method to solve it. And we have another method to solve it. 7 raised to the 3x equals 20. So what we're going to do is we're going to look at two different methods. Method 1 is going to be putting it into log form. And method 2 is going to be taking the log of both sides. Okay, so two different methods. All right, so the first one we should be pretty comfortable with. We know how to go from exponential to log form pretty quickly. So who can put this into log form for me? Log base 7 of 20. Great. Log base 7 of 20 equals 3x. Not so bad, right? Okay. What am I solving for? X. What's in the way? The 3. I don't want it there. How do I get rid of it? Good. I'm going to divide both sides by 3. And notice I divided the whole thing by 3. Okay? Remember, I'm solving. I'm evaluating for x. So all I have to do to get that value of x is plug my left-hand side into my calculator. Okay? So log base 7 of 20 divided by 3. I'm going to add in a calculator page here. Fraction template. Everybody should be doing this, not just me. Log base 7 of 20 over 3. And notice what it looks like. Okay? It has to look like it did on the paper. The whole thing is being divided by 3. If you type it in differently, you're going to get the wrong answer. Okay? And I get 0.15132. Are you okay with that? All right. One, 3, 2. 0.5132. I got my numbers backwards. Okay. All right, so second method, ready? That's it, that's the answer. Not so bad, right? Put it into log form and solve. So the second way is a little bit different. You do have to know how to do it both ways. We're still going to be using log, but with this method, we're going to take the log of both sides. So what that means is we're going to put a log in front of both sides of this equation. Okay, log. What I do to one side, I do to the other. Okay. Now, we know with our rules for logs, when I have an exponent, where do I put them? I put them out front. So 3x log of 7 equals log of 20. What am I solving for? What's in the way? The 3 and log of 7. So I want to get rid of them. How? Divide. So we're going to divide both sides by 3 log 7. Because it's multiplication, so it doesn't matter the order, right? Yeah. Okay, so to get that value, same thing, yep, log of 20 divided by 3 log of 7. Fraction template, log of 20 divided by 3 log of 7. Notice I'm not putting in the bases, right? What's the base if I don't put it in? 10. What kind of logarithm is that? Common. We getting the hang of that? Okay. Do we get the same answer? Absolutely. Okay, so either one of these methods is appropriate. They both work. They're both correct. Okay? Okay, let's take a peek at the next one. 3 to the x equals 4. Okay, 3 to the x equals 4. So 3 to the x equals 4. We're going to do both methods, method 1 and method 2. All right, so I'm going to give you a minute. I want you guys to do these out, see if you can get them on your own, and we'll come back. Okay, so who wants to set up method 1 for me? Log base 3 of 4, not to the 4. This is not an exponent. Remember that. Equals x. And I can very quickly throw that in my calculator, and I get, can I have agreeance here? Do we agree? Not everybody at once. I mean, that would be overwhelming. Yes? Okay, so how do I do the other side? Okay, so log 3 raised to the x and log 4 raised to the, never mind. Okay, now what? X out front, good. Okay, great. Great. What do you think? Not so bad, right? Okay. All right, so we're going to do one more. All right. 6 raised to the 2x equals 21. 6 raised to the 2x equals 21. So, both methods. And just so I don't forget, your homework, the homework for the entire lesson is pages 16 through 19. You're really only going to focus on page 18 tonight. This lesson is going to take us 2 days. Okay? All right, so go ahead and give it a shot. All right, Sandra, tell me how to set it up the first way. Base 6. Yep, of. Good. Now what? What am I solving for? What's in the way? How do I get rid of it? Good. Divide both sides by 2. And what do you get for x? Somebody want to help her out? 850.
Well, 84959. So
0.84895. 8495. 6 because it rounds up. That's what I thought. Okay. Other side. Who wants to walk me through this one? Tell me. No. Log of 6 to the 2x. Nope, no base here. Base is 10. Good. Good. Bring that 2x out. Okay. Good. Divide both sides by 2 times log of 6. 0.8496 when we round it. Okay? Great. You guys pretty comfortable? Not so bad, right? Just page 18 tonight. There's only one that might be a little concerning to you, which would be 4b. Okay, so let me just, since I have you here, 4b looks like this. 50 times 2 raised to the x equals 1,000. Do I like that 50 there? No, because I like it to be just the exponential piece equal to a value. So all you're going to do before you start is divide over the 50, and then either take the log of both sides or put it in log form. Okie dokie?